Imagine Mars, a world painted in hues of rust and ochre, a landscape vastly different from our own vibrant Earth. It's a cold desert, where the sun casts long shadows across the dunes, all beneath a thin, pink sky, a constant reminder of the planet's delicate atmosphere. As the fourth planet from the Sun, Mars occupies a unique position in our solar system, close enough to study in detail, yet far enough to hold on to its mysteries. Mars has fascinated humans for centuries, sparking our curiosity and driving us to look beyond our own world. Its landscape features towering volcanoes, colossal mountains that dwarf anything we have on Earth, testaments to a geologically active past. And vast canyons like Valles Marineris stretch for thousands of kilometers, carving deep scars into the Martian surface. These formations were shaped by lower gravity, just 38% of Earth's, allowing for the creation of geological wonders on a scale we can barely imagine. Mars's two tiny moons, Phobos and Deimos, are intriguing celestial bodies in their own right. These small, irregularly shaped moons are likely captured asteroids, forever bound to Mars's orbit, circling the planet quickly and at a relatively close range. A Martian day, often referred to as a sol, is remarkably similar to our own, lasting just over 24 hours, providing a familiar rhythm in an alien world. However, a year on Mars lasts 687 Earth days, nearly twice as long as ours, resulting in seasons that stretch out, painting the landscape in slow, subtle changes. The presence of ancient riverbeds and the discovery of various minerals strongly hint that Mars, in its distant past, once had flowing water, a crucial ingredient for life as we know it. This tantalizing evidence raises a profound question. If Mars had water and potentially a thicker atmosphere, could it have supported life even in its simplest forms? To answer this question, our robotic missions tirelessly search for clues, searching for signs that life may have once existed, or perhaps even still exists, on this seemingly barren yet potentially life-bearing distant world. Mars remains a cosmic neighbor, a constant presence in our night sky, holding secrets that continue to drive our exploration, pushing the boundaries of science and inspiring us to reach for the stars. Mars, the rusty red planet, presents a stark and unforgiving environment. Its character is profoundly shaped by its atmosphere, a mere whisper compared to Earth's, and overwhelmingly composed of carbon dioxide. This thin veil of gas has far-reaching consequences for the Martian climate and surface conditions. One of the most striking features of Mars is its extreme temperature fluctuations. During the day, near the equator, temperatures can rise to a relatively mild 20 degrees Celsius, 70 degrees Fahrenheit, offering a brief respite from the cold. But as night falls, the thin atmosphere offers little insulation, and temperatures plummet dramatically, reaching a frigid minus 73 degrees Celsius, minus 100 degrees Fahrenheit. This daily freeze-thaw cycle presents significant challenges for any potential life, as well as for robotic missions exploring the surface. Adding to the planet's volatile nature, Mars is prone to immense dust storms. These storms can begin locally, but sometimes they grow to engulf the entire planet for weeks on end. These planet-wide events block out sunlight, severely limiting the power supply of solar-powered rovers and hindering scientific observations. They pose a significant challenge to our robotic explorers, testing their resilience and durability. Like Earth, Mars experiences seasons, a result of its axial tilt. These seasons bring about dramatic changes, particularly at the polar ice caps. These caps, composed of water ice and carbon dioxide ice, dry ice, undergo a cycle of growth and shrinkage as carbon dioxide freezes out of the atmosphere in winter and sublimates back into gas during the warmer months. This process significantly alters the atmospheric pressure and wind patterns on the planet. Another critical difference between Mars and Earth is the absence of a global magnetic field. Earth's magnetic field acts as a shield, deflecting the harmful solar wind. Without this protection, the Martian atmosphere is directly exposed to the constant barrage of charged particles from the sun. Over billions of years, this relentless solar wind has gradually stripped away much of Mars's original, potentially thicker atmosphere. This atmospheric loss is believed to be a key factor in transforming Mars from a potentially warm, wet world capable of supporting liquid water on its surface to the cold, dry desert we observe today. By studying these environmental changes, we gain valuable insights into the factors that determine a planet's habitability, the conditions necessary for life to arise and thrive. While Mars's current environment is undeniably harsh, it holds a wealth of information about planetary evolution. Each new discovery, each piece of data gathered, brings us closer to understanding the delicate balance that sustains life, not only on Earth, but potentially elsewhere in the universe. The Martian environment, with all its challenges and mysteries, is both a formidable obstacle and a tantalizing key to unlocking the profound secrets of life beyond Earth. Its study is paramount to the field of astrobiology and our quest to answer the age-old question, are we alone? The distance between Earth and Mars is vast and ever-changing, a cosmic gulf that presents significant challenges to space exploration. It's not a static measurement, but a dynamic range that depends on where each planet is in its orbit around the Sun. At their closest, a moment known as opposition, the planets are a mere 54.6 million kilometers apart. This is when Mars appears brightest in our night sky, and when interplanetary travel is most efficient. But at their farthest, during conjunction when the Sun lies between them, they can be over 400 million kilometers apart. This vast difference has profound implications for mission planning. This cosmic dance, dictated by orbital mechanics, means launch windows for missions open only every 26 months. These windows are critical for minimizing travel time and fuel consumption. Mars orbits farther from the Sun, receiving just 43% of the sunlight Earth does, contributing significantly to its frigid climate. This lower solar irradiance also affects the power generation capabilities of solar-powered rovers and landers. These distances affect everything, travel time, dictating the duration of missions and the resources required to sustain them. Energy needs, demanding efficient propulsion systems and careful management of power throughout the journey and during operations on the Martian surface, and even communication, posing unique challenges for maintaining contact with spacecraft and rovers exploring the Red Planet. Radio signals, traveling at light speed, still take 3 to 22 minutes to cross the gap, depending on the planet's relative positions. This delay necessitates a different approach to controlling Martian robots. This significant delay makes real-time control of rovers impossible, requiring them to operate with a degree of autonomy, executing pre-programmed commands, and making decisions based on their onboard sensors. Every command sent to Mars is a leap of faith, with scientists waiting patiently for a response, knowing that unforeseen circumstances on Mars could impact the mission's success. The vastness of space between our worlds is both a barrier and an inspiration, fueling our desire to explore and understand our place in the cosmos. Each mission is a testament to human ingenuity and patience, pushing the boundaries of what's possible. The journey to Mars is as much about overcoming distance as it is about discovery, a testament to our relentless pursuit of knowledge. Our connection to Mars is defined by these immense shifting distances, shaping the way we explore and interact with the Red Planet. Yet we persist, bridging the gap with technology and curiosity, driven by a fundamental human desire to explore the unknown and expand our understanding of the universe. Traveling to Mars isn't a simple trip. It's a carefully timed journey through space. Spacecraft follow a curved Hohmann transfer orbit, launching only when Earth and Mars align every 26 months. The voyage takes 6 to 9 months, with astronauts facing isolation, confinement, and dangerous cosmic radiation. Protecting crews from radiation is one of our biggest engineering challenges. Arrival is the most perilous phase. Spacecraft must slow dramatically to enter orbit or land, using heat shields, parachutes, and rockets. This 7 minutes of terror has claimed many missions. Each successful landing is a triumph of precision and perseverance. The journey to Mars tests our technology and our resolve. Every mission brings us closer to setting foot on another world. Mars travel is a bold leap into the unknown. Our exploration of Mars is a robotic saga. Orbiters, landers, and rovers have revealed Mars's secrets, from Mariner 9's first global maps to Viking's search for life. The tiny Sojourner rover proved we could drive on another planet, paving the way for Spirit, Opportunity, and Curiosity. Opportunity's 15-year journey confirmed Mars once had liquid water. Curiosity, a mobile science lab, found evidence that Mars could have supported microbial life. Perseverance, our latest rover, hunts for signs of ancient life and collects samples for future return. Ingenuity, a small helicopter, achieved the first powered flight on another world. Each mission builds on the last, expanding our knowledge and capabilities. Robots are our pioneers, preparing the way for human explorers. Mars's story is written by the machines we send. Could Mars become humanity's second home? Today, it's a hostile world. Thin air, freezing temperatures, and deadly radiation. Early human missions will be short stays, focused on learning to survive and use local resources. Astronauts will test making oxygen, extracting water, and growing food in Martian soil. In situ resource utilization, using what Mars provides, is key to long-term survival. Water ice in the soil could support life and fuel production. Turning Mars into a true home would take generations and raise ethical questions. Should we change another world? What if life already exists there? The dream of a habitable Mars challenges our technology and our values. Our journey is as much about wisdom as it is about exploration. Terraforming Mars means transforming it into a world humans could walk on without spacesuits. The first step, thicken the atmosphere and warm the planet, perhaps by releasing greenhouse gases or focusing sunlight on the polar caps. As Mars warms, water could flow again, forming rivers and shallow seas. The sky would turn blue, and clouds and rain would return. Making the air breathable would require introducing life, engineered algae and bacteria to produce oxygen. This biological transformation could take thousands of years. Terraforming is a colossal, multi-generational project, part science, part dream. The vision of a living Mars inspires us to imagine what's possible.